Okay, so what is a function? Okay, majority of math experts claim that a function is a relation in which every input has exactly one output. So here we go. We got the example, which is a running faucet. And here are our values. We got the number of minutes for the running faucet. So let's suppose that function. So 15x. So 15 is the only given number. Suppose that we don't have the other values here. To get the other values, we are going to substitute the x right here. And obviously, if there's an x next to 15, it serves as a simple way to represent function, which is 15x. Then let's put 15 times 2 as a substitute to that. Then we got 30. 15 times 3, 45. 15 times 4, 60. 15 times 5, 75. Then 15 times 6, 90. What is the purpose of 15, or what's the purpose of these? Okay, now that we have this, we can create our ordered pairs and we can have a graphical representation. And you notice that there is only one output, unlike others that have same unison type of outputs or even inputs. That's usually not a function, that's only a relation. But here, let's focus more on the graphical representation, on how we can also make a graphical representation. So ordered pairs. We can simply make an ordered pair through here. So here is your domain, guys. So 1, 2, 3, 4, 5, 6. So the pair for 1 is obviously 15 because this is its output. Then the pair for 2 is 30 because that's the output for 2. Then 3, it's 45 because that's the output for 3. Then the same goes for 4 to 6. And now we can understand there are the x coordinates. It belongs below here because these usually are the independent variables, and the independent variables represent as the number of minutes the faucet runs, while the number of liters of water wasted is right here. It's from 0 to 150. And again, we base from 15, then x. We substitute that x so that we will know through these independent variables the product for the second one. So this one is really dependent so that we can understand, or should I say we can complete the entire variables for the y coordinates. So to plot the points, we just simply gotta have to do a matching type as we keep it in simple terms. So we put 15 and 1 right here. As long as they're aligned in the paper like this, there's usually a measurement, but it's usually represented this way, especially in smaller paper or test papers. And so we have 1 aligned to 15. So we put the points here. 2 to 30. 3 is to 45. 4 is to 60. So we're just going to align everything based from the ordered pairs right here. Based on this graphical representation, the 150 is the largest number of liters of water wasted here in this graphical representation. And the smallest number, the lesser one, is obviously 15. Then the largest is 150. So I think you're getting the whole point and you're able to grasp the entire idea. Okay, to understand this more, focus on the x coordinates when it's given a relation. So it's a relation, a function. Okay, we mentioned this a while ago. We're going to make it quick. If the set of ordered pairs has different x coordinates, then it is a function. Like the ones we have 1, 2, 3, 4, 5, or 2, 4, 6, 8. If it goes that way, that's a function. The set of ordered pairs that has the same x coordinates is not a function. Let's say 0, 0, 1, 2. That's automatically not a function. That's just a relation. But at least you're getting the whole idea. Y coordinates have no bearing in determining determining functions. So those are things that you have to keep in mind so that you can identify whether it's a function or just simply a mere relation. Okay, so we got example 3. And of course, it's stated right here. Is this a relation? Yes, it is. And is this a function? Obviously, it is. Why? Look at that. 0, 1, 2, 3, 4, 5. So focus on the x coordinates. They are all different. Therefore, it's a function. Simple. Then here, the next one. Okay, it's not a function. But it is a mere relation. It is a relation because we can still use these and it's still represented as ordered pairs. Why is it not a function? Look at that. 0, 0. That's automatically not a function. There's no function right here. So which relation mapping represents a function? Why is it choice 1? Okay, I'll explain it. So for function, again, we shouldn't have the same x coordinates. Choice 2. Why is it not the function? I mean, look at that. -1 is paired to 3. Then -1 is again paired to -2. Right here, 3 is only paired to -1, 1 is only paired to 2, then 0 is 2. The y, it doesn't matter if the y coordinates are the same, but if the x coordinates are the same, then that wouldn't serve as a function. There's no, it's not a function. So this is how you can easily identify that it's not a function. Okay, so which relation mapping represents a function? It's B. I'm sorry, there's no B right here. But this one represents a function because there's only one x coordinate that's matching with a y right here. Should I say that it's only it only functions once, unlike here where it is used multiple times? Yes, it's a relation. You can create an ordered pair, but no, that is not a function. It's just a mere relation. We can also identify a function through a vertical line test. And again, the ordered pairs are very important because we are able to use it here and we are able to plot points. So this is how you're going to apply it. Okay, would this graph be a function? So it would be nice if you had a pencil, then you put it right here at the you put it at the Cartesian plane of the right side within here, which is the x and the positive side x. Then we got y, and let's apply. And if it actually hits one point, then we can state that yes, it's a function. Okay, this one, is this a function? Put your pencil. Oh, it should be right here in the middle. It's not working. The effects are not working. Please put this pencil. Let's imagine that you put this pencil here. Let's move it right here to the right side. Then we will know that this is not a function because there are 2 points hitting it. And the function is only presented once, not twice, or we don't use it twice. It's not applied twice. So that's how we can simply put it. There are 2 types of functions, discrete and continuous function. So a discrete function is a function with distinct and separate values. This means that the values of the functions are not connected with each other. Okay, in Tagalog, we can simply say that pakalat-kalat yung mga points, or should I say the points are not, let's say they're not at one place. They're scattered, they're everywhere. They're all over the Cartesian plane. And continuous function, this is like the one line that we were able to represent a while ago, the one that we used for the vertical line test. That's the perfect example for a continuous function. Okay, judging this graph, what do you think this is? So, okay, before we identify it, again, this is how you plot the points. So here we got the domain of -7, 1, 5, 7, 8, 10, then range of 1, 0, -7, then 5, 2. Okay, so obviously the pairs are right here, but we can understand that we don't need to do ordered pairs when it's already a Cartesian plane because the Cartesian plane serves as a representation for this. For example, this one, -7, it obviously belongs here. There we go. 1, that one goes here. And of course, it's strange. It's right there. The 0, please don't mind that for now. And then you plot each point right here. Just count. You're just going to base it from, for example, 5. Okay, 5 is positive. Now you put 5 right here. Okay, 5 is aligned to 7. So you put 5 is to -7. You put it below here because we got the set of ordered pairs, excuse me, to align it each basing on their pairs. It's depending on the domain. Is it discrete or continuous? It's discrete. So again, the hint here, it's scattered. It's all over the place. Okay, so what is this domain? Judging by the line, what do you think it is? 3, 2, 1. It's continuous. Tell me if this is continuous or discrete. 3, 2, 1, 0. And here we go. It's continuous. Nice. You based on the line. Okay, how about this? This one seems, let's say that it's infinite. It can go infinite, like an infinite line, like a parallel line. So what do you think it is? 3, 2, 1. Discrete or continuous? It's discrete. Why is it discrete? Scattered points right here. It's not a line. So example 7. So which situation represents a function? Tell me. So A states that the items in the store to their prices on a certain date. Is that a function? Or types of fruit to their colors? Okay, I'm going to give you 3 seconds to guess. 3, 2, 1. Okay, the right answer is the items in the store to their prices on a certain date. Why? There's only one price for each different item on a certain date. The relation from the items to make price is a function. Okay, the types of fruit, such as an apple. Okay, if you chose B, it's not it's inaccurate, but great, nice try, but it's not right because of this. A fruit such as an apple from the domain would be associated with more than one color. Then there's red, green, and of course, since these are the relation of the types of fruits to their colors, that wouldn't serve as a function. It's not We cannot really picture it, but we can say that it's a relation, a mere relation. There is a relationship between the fruits and their colors, but we don't really know the function between the two because it seems like there will be some numbers repeated again, especially for the x coordinates. So keep that in mind. Pete's Pizza Parlor charges $5 for large pizza with no toppings. They charge an additional 1.50 for each of their 5 specialty toppings. I think a lot of you are wondering, what does Pete's Pizza have to do with our lives and this, and how can it be even useful for real life? Okay, for people who are into business, who are going to that kind of world, accounting or even financing, this is actually, it's more applicable for business, but if you're like the financer of that business, it's going to be useful. So that's why it's useful. Domain and range is also useful in real life. And again, let's identify the independent variable. What is the independent variable? Okay, I'll give you time to guess. 3, 2, 1. So the independent variable right here is the number of toppings. Why is it the independent variable? Okay, to make a pizza. So the pizza is already $5. And of course, in business strategy, that's very cheap. That's a large pizza and you can only get it for $5. But there's no toppings on it. Of course, in Tagalog terms, we can say that babawi sila sa number of toppings. Dun sila kikita. Okay, and that's how they're able to. So the cost of the pizza depends on the number of toppings. So let's say that this 150, you want 10 toppings, and if we're gonna multiply this by 10, it's gonna be 15. 15 plus 5, because this is the price. $15 is the only price for the toppings. We haven't discussed about the $5 for the large pizza. 15 plus 5 is just a usual $20 pizza. So again, some people apply that, or should I say some restaurants do that. So yeah, you can use domain and range in real life. You have these is this is actually used for a when you're analyzing prices and stuff like that. When there is a relation between the price of like additional toppings, additional drinks, like that. When you're buying a set instead of an a la carte in McDonald's, there is domain and range in that as well. So I hope you learned from me. I hope that you were able to enjoy this lesson. Thank you so much for being attentive. I hope that this will become helpful to you. Don't hesitate to ask me questions if you have some, and have a nice day.